Hi, I'm Bill Schonger. I'm the Resource Area Manager for the 3D Printing Resource Area here at MakeIt Labs. We've got both FDM and resin printers. We're going to be taking you through this area to explain what that means, what are they for, what can you do with them, and how hard is it to start using these. So join us as we start walking through this area and expand on what we've got and what you can do with them. So for these machines, which use filament to produce the object, they use a roll of plastic filament similar to this, which is about 1.75 millimeters in diameter. And this thread operates much like a hot glue gun. You feed this plastic material into this hot end. It goes in through the top, this hole here. It gets pushed through motors out through the bottom. It's heated up by power coming through these wires, and this section gets really hot. And it comes out as a thin stream of plastic material, making little lines that the machine then draws back and forth in a pattern, normally oriented in this direction, to create your pattern on a layer-by-layer basis. Once it's done with all the lines in one layer, it raises up slightly, draws all the lines for the next layer, and keeps going until it's done. This is another one of our FDM printers. This is a Bambu Lab X1 Carbon, of which we currently have 2, and we're expecting a third one at the end of April, which is a slightly larger and newer version of this that was just released, called the H2D. Can't show that one today because it's not here in the shop yet. We're looking forward to adding that to our collection. Like the Adventurer 4s, these are FDM printers. They operate on filament. You can see at the top there are 3 different spools of filament feeding into this machine through what's called an AMS, or an Automated Material Management System. The advantage of the AMS over the other printer is you can feed multiple spools of filament here of the same color. So when it runs out one in the middle of a large project, it can automatically pick up with the second roll of the same material and keep going. So you have to change the spools less often. A bigger advantage of the AMS is you can use different colors of materials or even different types of materials in the same print. So if you want to print something that uses a support material, which is what holds up certain parts of the print that would otherwise fall down because gravity takes effect on molten plastic, or if you just want to have different colors of prints, in some of the examples we'll show you shortly, having this capability allows it to switch automatically for you with no manual intervention, saving you a lot of time. What you'll also notice with the X1 Carbons is they are an awful lot faster than the Adventurers, to the tune of approximately 8 to 9 times. This is a huge time saver for any of your projects. They are a lot more reliable, they are newer, they are more accurate, and we'll show you some of the examples that these printers are capable of, where right off the build plate you are ready to go with a finished product that's ready to use. As you noticed in the top of the X1 Carbons, that AMS with the multiple spools of filament has the ability to hold multiple spools. One trick it has up its sleeve is determining what type of material you're putting in, including what color it is. Now, it uses a nice little trick to do this, which is an RFID tag. The RFID tag is inside the spool, which we'll show you in a little bit more detail, and the RFID tag contains information on what material it is and what color it is as provided by the manufacturer. These are refillable spools, so you can buy a cheaper refill with the same RFID tag and reuse your spool for a different type of material. There are more than a dozen types of materials that are compatible with this machine, so it becomes very important to automatically know what type of material you're using to make sure your settings are correct and you don't accidentally print something and fail, especially if you're using a more expensive filament. MakeIt Labs does have a stock of filament for the Bambu Labs printers on hand, and what we charge members is exactly the price that we pay for it when we buy it at bulk, allowing you to quickly use the machines without waiting to get an order of filament in just for your particular project. So this is an image just showing again what we covered when talking about how FDM printers work. A spool of filament of various material is pushed from the spool down into the hot end and comes across as these layers, these lines that stack up kind of like Lego blocks. But how does it figure out how to take a 3D model and turn it into these patterns of lines? It needs a set of instructions. Where do those come from? Those come from a piece of software called a slicer. Now, there are different slicers based on the type of printer you're using, the specific model of printer you're using, and we're working to unify that into one interface that looks a lot more like this. You'll find out more information about that during training. So this is the model we tend to use in training, called CaliCat. Now, I've added to the build plate. I can rotate it around so you can see this is a 3-dimensional model. There's a lot of instructions that you can give the printer as far as what to do with this model. We're going to stick with some very basic things since this is a very basic model. In this case, in this software, we're telling it what printer configuration we're using, including the build plate, as there are different types. We're telling it what material or filament to use. In the case of the X1 carbons with multiple filaments, it's possible that we could have a whole variety of materials that we want to select from, or even a whole different variety of materials loaded. And so we want to make sure that we're setting our parameters based on the correct material for the correct printer. Over here, you'll see other things such as the layer height and all sorts of technical details that you can learn all about as you go through training and practice with objects. But at a very basic level, all we need to do is load our object, be sure it's the right printer, the right build plate, the right material, and the right layer height. And we can go to this button called Slice Plate, and it has now prepared this model into what's called G-code. G-code is a set of instructions similar to what many of our other machines here at MakeIt Labs use that say, okay, for this printer, for this tool, I want you to take the following movements. Push filament through the extruder motor, move the thing left, move the thing right, move it up and down. Behind the scenes, it's a whole bunch of simple commands. If I drag this slider on the right-hand side, I can look and see what each individual layer of this object is going to look like as it's printing to help me understand better, as I zoom in, if I'm on the first layer, what should it look like? And this is important because one of the ways things can go wrong with 3D printers is your layers don't come out looking like you expect them to look, or especially the first few layers don't stick properly to the build plate. So if I'm watching this print when it first starts and the shape I'm seeing drawn on the build plate does not look like this, I know that something's wrong and I can stop it and try and figure out what's going on. Now normally with these printers that's not very common, but like anything else, practice makes perfect, and it's slightly more of an art than a science in some cases. Now you may be asking yourself, when it's printing, what if I actually want to see what it's doing? I could wander over to the printer, squat down and squint and try and see what it looks like. Or, once it's printing at a device, there's a device tab, and I'm going to use one of our running printers as an example, where you can see at that low macro angle what's going on to look for potential issues. So this allows you, without getting out of your chair, to watch the first few layers, see if everything's going okay, and then take action from there if necessary, which is pause it or stop it, or realize that you put in the wrong color, all those kind of things. As with any software, there are a lot of nuances to learn, and this video does not attempt to convey all the potential complexities you'll run into, but it can be just as simple as you saw. Slice this, hit this button to print plate, and it sends it wirelessly to the Bamboo X1 carbons. For the Adventurer 4s, there's a similar set of software, but that's an older version, and we're trying to migrate to a newer version of that software that's much closer to this interface, allowing people to move between tools, between printers, with a minimum level of effort to try and learn the software itself. So the other type of printers in our shop are resin printers. We have two currently. We have an Anycubic Mono 5S, and we have a Sonic Mega 8K. As you can tell, one is far bigger than the other. But what's the difference between a resin printer and an FDM printer? Well, a resin printer uses resin. So this is a light-sensitive UV resin that cures because there is a light inside these printers, so that as the resin goes down, just like UV hardening epoxy or similar things, the light shines and hardens the material. But how does it really work in the end? You have a tug of war between two parts. The build vat that holds the resin, and the build plate where your object goes. As you fill this with resin, this plate drops down, squishes the bottom, comes up a tiny little bit. The light hardens the resin on both the clear sheet on the bottom as well as the build plate. And then there's a tug of war between these two objects. Hopefully the build plate wins. If it does, the layer of plastic that's hardened sticks to the build plate, lifts out of the vat. It goes back down in position for the next layer. Again, the light hardens the resin. There's another tug of war. Hopefully it sticks to the previous layer. It lifts up and it repeats. Much like the software used for the FDM printer tells it how to draw in lines, resin printers draw in light. So it's one layer of light at a time, not tiny little laser pixels or anything else. Think of it like a screenshot on your phone, where there's a screenshot of each individual layer, and the light from that screenshot is what's projected onto the screen and hardened. The one advantage of resin printing is its super high detail. So these little tiny objects have an incredible amount of detail, The one downside to resin printing is it is hazardous. So we're not going to turn it on, but we have a vent fan in here that is to be used anytime you're doing resin printing. The resin that you're touching is hazardous. You want to wear gloves, you want to wear ventilation equipment, face shields, anything else you need. So anytime you're working with resin, there's far more to consider than the ease of use for the FDM printers. So we recommend the resin printers only when your particular application requires it. Now, if you're a miniature war gamer or someone else doing D&D miniatures like this little fellow or similar, these are the printers you want to use. The super high level of detail, the amount of things you can print on this, and just the overall level of capability is quite high. The other fun advantage to these is while an FDM printer draws one line at a time, because it has one head, because that entire screenshot is being projected on here at once, in resin printing it doesn't matter whether I'm printing one of these objects, or 8 of these objects, or 10 of these objects, or 12 of these objects. It's going to be the same amount of time because it's that same one screenshot all curing at once. So this is something to consider if you're making lots of tiny little things, is this may be a good application of the resin printer. So there is an in-person class for using the resin printer. You cannot self-authorize on these due to the hazards, where we walk you through how to properly protect yourself, how to design your model, and how to overall get these printers to work for your specific application. We're going to show you the slicer software that's used for these, which is slightly different than the FDM slicer software, but operates on the same principle. Put in a 3D model, make sure the model is ready to print, and account for some of the trickery of resin printing, and then go ahead and send it. These do not operate over wireless connections. You do have to take an SD drive and plug it in with your model in order to print them. Printing time on these can take anywhere from about 10 minutes to, again, many, many hours, depending on the size of your object. Or if you're using the big fella over here, a day, maybe more, if you're printing a helmet or something crazy. So for the resin printers, again, there is a slicer involved which takes your 3D model and prepares it for use on the resin printers. So we're going to open up a recently opened file here. Let's find, I don't know, somebody's miniature here. Okay. Now, as you can see, if those of you that are familiar with desktop gaming and wargaming, Dungeons and Dragons, all those fun things, this is a mini. Someone's going to print a mini, use it in their campaign, do other things. It's very small. You saw the size of the other figurines. You know, these are less than 2 inches tall in some cases, and that's a huge level of detail for a very small model. But these resin printers print at a layer height of 0.05 millimeters, half the thickness of a piece of paper. So they are capable of capturing an awful lot of detail. Now, unlike the Calicat, which I brought into the FDM slicer, if I were to hit just slice and go, this would fail very miserably. And that's because there is nothing attaching parts of this to the build plate, which would cause that tug of war to fail very miserably. As you got to the shield, to the sword, to other parts, it would just lose. So it uses what are called supports to actually then do something with this file. And so I'm going to say, you know what, automatically support everything. And it's going to try and generate this little bridge structure of what it thinks is necessary to hold this to the build plate and ensure that resin flows properly to all the parts. Now, as part of the resin printer training, we'll go into the complexities of how you orient a model and what you're looking out for and the problems you can run into. But a very basic level to remember is that resin printing, unlike FDM, is going to involve more time in both the preparation as well as the cleanup of the model, because all those hazardous chemicals, all these supports need to be removed, the tray needs to be cleaned out to decontaminate it before another color or type of resin goes in. So there's a lot more involved. But the benefit here is if I need to print out 20, 30, 40 of these little fellas or different models on the same plate at the same time for a campaign, I can place them all over the plate and I can be ready to go. So in the slicer software, when I'm done and I'm ready to take this model, I would just slice this. And what it's going to show me is a couple of interesting things. How many milliliters of resin it takes, how much it's going to weigh, how much this is going to cost me in resin, similar to for filament prints, how the other slicers will tell you how much it's going to cost in actual filament that you pay for. And if I scroll down through these layers, kind of like we did in the other software, what you're seeing is the screenshot that is being displayed on the printer as it's hardening the resin on that layer. So this is literally the pattern of light that's going to be displayed on the printer that causes the resin to harden. So by scrolling through here, I can look for things where I'm seeing patterns I don't expect, or areas which don't seem to be connected, as well as there are some different tools such as island detection, which is going to help me understand if I don't see any major issues with it, are there minor issues of little things where I might want to add additional support. And you can spend quite a while on these optimizations before you get the optimal print. So in some cases, models that you purchase may come pre-supported, where the author or the designer has spent that time putting in the supports where they know it's going to be necessary to give you the best possible experience. So consider that when you're buying or creating these miniatures or other files, that's going to save you an awful lot of time and ensure a lot more success. In the class, we talk more about the different types of resin, how they affect prints, and how you calibrate your printer and your settings to make sure you get the best possible results. As you can see, with some of those small items, when you're dealing with that much detail, it's worth the time spent to actually get things right with tests before you go trying something that's going to take a lot longer. As we mentioned, the X1 carbons can hold a variety of different filaments, multiples at once, and there are a lot of different types of filaments, from your basic PLA to what are considered engineering grade filaments with carbon fiber or glass-filled ABS, things capable of making strong car parts. Your selection of material will vary based on the particular application, and one of the things that we're here to help with is help you experiment with different types of filament we have in stock and help us pick what new types of filament we should bring in that may be useful for your new projects. At any point in time, we tend to have 12 to 15 different filaments minimum in-house and ready to use, and we're always taking surveys on the Resource 3D printing channel in order to find out what we should get next, including colors and types. So take a look at what we've got in stock, think about how it fits your projects, and let us know what would help you most. Thanks for coming by for this brief tour of the MakeIt Labs 3D printing resource area. We hope that what you've seen has been of interest for some of your projects or gives you some ideas of things you might want to learn. You can create almost anything with 3D printing, and we hope that you'll take some time to give your ideas some thought and see how you can bring them to life in here with what we have. For any questions, please feel free to reach out to us. We look forward to seeing you in our training classes.